Integration by partial fractions, Part 2, Linear Factors, this time with integration. If you would like to see how to do partial fraction decomposition, look at Part 1, Integration by partial fractions. First question I want to ask about is, how do you know when to use partial fraction decomposition? Well, there are two things I look for. First thing I look for is the denominator easily factorable. Which it is in our first example. But also, we can't use an easier method. So I'm going to use partial fractions when my denominator is easily factorable, but there is not an easier method to use. So, easily factorable over here. Can't think of an easier method right now. So I will do a partial fraction decomposition, which says I can do a over one of my linear factors plus b over my other linear factor must equal 5x over x plus 2 times x minus 3. Let's go and solve this one. We'll find a common denominator. So I'll get a times x minus 3 plus b times x plus 2. Get a common denominator. We're going to ignore it and solve across the top. Equals 5x on the other side. Let's choose values for x. I will choose x equals 3. Plug it into both sides of this equation, which gives me a times 0 plus b times 5 equals 15. So b equals 3. Let's choose another value for x. We'll do x equals negative 2. This gives me a times negative 2 minus 3 plus 0 equals negative 10. Because I have to plug x equals negative 2 into both sides of my equation. Negative 5a equals negative 10, or a equals negative 2. So the integral 5x over x plus 2 times x minus 3 can be written as the integral of a over x plus 2 plus b over x minus 3. And now we can easily integrate each of these pieces. So I get 2 times the natural log of x plus 2 plus 3 times the natural log of x minus 3 plus c, our constant of integration. Let's do one example with repeated linear factors. Again, you can go back to the first video and see how to do the algebra of it, but we'll assume that you have watched that and understand it. We're going to take our integrand and use partial fraction decomposition. So I need an a over x, but I really have x times x, so I need b over x squared, and then c over x plus 4. which should equal 16 over x squared times x plus 4. Let's do the common denominator. The a needs an x and an x plus 4. The b fraction is only missing the x plus 4. The c fraction is missing an x squared. Then we have the common denominator, which we ignore because we solve across the top, which means it must equal 16 on the right side. And let's choose values of x. That will make things disappear, hopefully. So if I choose x equals 0, I get a times 0 plus b times 4 plus c times 0 equals 16. 4b equals 16, so b equals 4. Let's choose x equals negative 4 to make some of my factors 0 here and here. And I get a times 0 plus b times 0 plus c times 16 equals 16. So c equals 1. Now, at this point, I choose anything. I'm hoping x equals 1 will give me some nice numbers. I can't choose any other x's to 0 factors out. So if I plug in x equals 1, I get a times 1 times 5 plus b, which is 4, we already found that, times 1 plus 4 times 5, plus c, which we already found, which is 1, times 1 squared, and that must equal 16. So we get 5a plus 21 equals 16. 5a equals negative 5, or a equals negative 1. So the integral 16 over x squared times x plus 4 can be written as the integral of a, negative 1 over x, plus b, 4 over x squared, plus c, 1 over x plus 4. And now we can integrate this one pretty easily. We get negative natural log of x plus, middle part is a power rule, negative 4 over x, plus, now we go back to natural logs, natural log of x plus 4, plus our constant of integration, c.